Hello, welcome to this tutorial. I'm Maurice Dimba, and today I'm going to show you how to create a footbridge supported on a curved braced steel beams. Let's get started right away. And if you can take a look on the screen here, you can see some triangles and a circle already in place and a grid line. I just want to explain this briefly. Now, this point, I have 2 points here. I have this point and I have this point here. This defines the length of my footbridge. Now, I transferred these 2 points, these 3 points. This is the midpoint. So I transferred these points up here by copying these 3 points up by 90 meters up and connecting the two to create a triangle and using this center to create a circle. So the key point here is to get the height of this curve where our curved beams will be located to support our footbridge on top here. Now, it's always okay to support your argument technically, or technically. So if someone asks you how did it come to define this curvature, so this is how I did it. I copied this at a height of 90 up here, and I joined this and joined that to create a triangle and created a circle. My main aim is to define the height of this curve. So what I'm going to do here, I want to show you how 2 ways of creating this circle. Another way through calculation, another way once you get the length or the height of that curve, you just use another way to create that curvature. Now we are going to mark this length or height as a V or a verse sign as it is, and we are going to use a formula to get this length. Or once you've created this, you can just go straight away. Some people go straight away and can measure manually, but if you're told to support it, it comes it causes a drama. Now I'll use a formula to create this. I'll come to edit, I'll come to measure, and I want to measure from this end. I want to confirm this measurement from this end, and I'll go all the way to this far end here. I'll snap right on that spot. And if you take a look at the bottom end here, we have 100 meters and 623 100.6 meters. That's it. And this measurement from this end, from that end to this end, let's just measure this to this end. This should be 90. This is 90 because it's the same with the bottom end one. Now the question is, what is this height? Because this is the profile that our curved beam will be following to provide support for our footbridge on top there. Now the formula will be very simple. We are going to take this length, we'll multiply by 4. We'll take this length, we'll square it and multiply by 4 and subtract this and subtract this, a square of this length from this, and divided by 2 and subtract again from this to get the verse sign. I'll show you that formula. Now what I'm going to do, I'll use an online calculator here. I'll just start afresh. I'll start afresh. Since we have this one in place, we have this this one is 100.6 meters. So what we are going to do, we are going to multiply 4 by that length, 600, 100 by 2, that, then we'll square this, and that is our result, and we'll multiply this one. We'll subtract a square of this length. Let me just go back. A square of that length, which is 90. I'll come to 90 meters there, and I'll square that. But I'll get a square of that. and that is our result. So what I'm going to do, I want to get a square root of this. So what I'll just go straight and get a square root of that, and 32, 39, 99, 52, and 51, 6. Now I'll get a square root of that. So this is what we have as a square root of this. This is a square root of this. So this one will divide this by 2, divide that by 2, and now we want to subtract this. We want to subtract this from this length, and to from this length to get this height. Now I'll go back to my calculator here. So in this case we have 89,999.4, 89,999.4. So I'll just go straight and subtract that, which is 100, 623. So we'll subtract that, 89,999.93 right there, and you'll have 10 meters, 10.623. 10.623. This is what we have. So this is the height. This is the height here. So if we copy this up, let's just try and copy it up, special copy, and we'll take it up by 3, 10,623. We'll copy it up. We'll copy it up. Don't expand because we don't want to use our lines. We don't want to lose our lines. So it's somewhere here. It is here. So another way, instead of doing the calculations, you just come to steel beam and come to click steel, then create your beam right there. Place the beam right here and snap right there. Just give it some time and the beam will be in place. Here we are, and our beam is already in place. Now I'll come to draw, I'll come to view and come to navigate, and I want to turn this like that to have a look at it. Now I'll double click on it once again and position it accurately. I'll click modify, and I'll double click on it once again to rotate it. I'll come to back and click that. I want to bring it right at the middle. I'll pick middle, and there is where we want it to be on. Now I'll come to navigate and turn that round. The size of the beam, you just leave it at default. The key is just to show you how to create the curved and braced beam that will help in supporting our footbridge. Now we've created this in place. This is in place now. So we want to use this measurement, this measurement here. We can copy that and come back to Tekla structures here and double click on this. Then we come to cambering and we'll feed the same measurement here and go ahead and click modify. It has gone the opposite direction, so we need to prefix this by a negative sign. We just place a negative sign right there and click modify. So you see it takes the exact curvature of this using the same measurement that we used. Now that's another way. Once you've got your calculations right, you don't need to draw all these curves and all these triangles. It's a waste of your time if you really know whatever you want to do and how to do it. Now I've created this. Now what I'm going to do, I want to just offset this I want to give this a span of 2.5 meters or 3 meters. So I'll click on that, right click and come to special copy here, click linear, and I want to copy it on the z axis here. Now I'll come to z axis here and feed 2.5. I just feed 2.5 here and click OK. So you can see that already in place. I've copied that now, and I want again to copy these two curved beams down by 2.5 meters. I'll come to special copy and click linear. So I'll come to z-axis and change that to 0 prior to copying it. So I'll come to z-axis, y-axis, and I'll paste the same dimension on the y-axis. And because the y-axis is facing up, now we need to prefix this with a negative sign right here. I'll feed a negative sign right there. Now I'll click copy, and it will be copied down here. I'll click expand and click OK. Right click, and now we'll check whether what we're doing is correct. I'll turn that, and this is exactly what we want. And this is the arrangement of the curved beams. This is the way I want them to look like. You can take a look how they look like. Now I want to brace these beams. Now bracing these beams is very hectic, because following this curve is another job that you really you'd not like to do, or will not like to be part of. Now I want to get the center of this beam and create and start bracing these 4 beams. Now I'll come to edit and pick a point here, and I want to select the center of this. This is my center. Now I'll come to view here and come to navigate, and I'll come to navigate here and rotate that. These are the points that I'm going to use to start placing the braces on these curved beams. I'll come to I'll come to beam right here, and I'll snap on that spot, and just place your cursor on that spot and type in the exact measurement you need to use. I'll feed in 2.5 and I'll give an OK right there. I'll come to interrupt and come to view. I'll come to navigate and try to rotate this. So you see my default beam size or beam description or beam property is a curve. So it will force me to go back and change that default setting. Now double click on it and change this. I don't need any curvature here. I'll click that. Now I want to reposition this, and prior to reposition this, I want to change the size of this, or I want to change the profile of this beam. I'll double click on it, then I'll come to this radio button here and click on it. This will take me to the catalog, profile catalog. In here I'll be able to change or pick a different beam size. I'll pick 254 here and pick on that. I'll pick, apply, and do the same thing. I'll come to position here. I want to reposition this to sit in the appropriate position along the curvature of these beams. Now I'll come to at depths and see whether this will work for us. I'll click front, and this will not work. This one will take it into a different position. We'll come to plane and give it left and see whether that will work. Right will work for us. So we'll give a slight offset of 50. We'll right or click on that and click move and come to y-axis here. And prior to coming to y-axis, make sure your x-axis and z-axis are 0. And once you're in your own y-axis, feed in 50 millimeter, and you want to take this down here. We prefix with a negative sign, and we take it down here. Again, take it down. It's slightly high, and do that. You undo, right click, and do the same thing. Give an offset of 20, or 20 will be okay, and give an offset right there. So click OK and come to navigate, and if you rotate that, it will be okay for us. That one will be okay, and still we can just add a little. Remember this just to show you how to play around with, how to create a curve that supports your footbridge. So this always comes after you've done the analysis, structural analysis, and the steel sections have been suggested which one to use and which one not to use, and which one to use and how to connect it to the others. Now as I'll select on that and come to special move, and I want just to add an offset here, just 5, and click OK. That's okay. Now I'll close this and come to navigate, and I want to rotate this. So I want to populate this beam, this supporting beam, this beam that supports these 2 beams on top, and populate it along this curve. How will you do that? We have a special tool called array tool. You just type array tool there, and we have polar array here. So how do you work with this polar array? We have options here. We have equal distribution by number of objects. which is my preference in this case. Now what I'm going to do is just to select the member that I intend to populate along this curve. I'll double click on it to open or to access this polar array dialog box. Now I'll select on it, right click, and once you've right clicked, you'll be asked you will be asked to point the first option, the first point. Now my first point will be this point here. I'll select that as my first point and zoom out, and on the same curve that I've placed my point, I'll go to the same curve and just define this point as my second point right there. Then I'll go to the other end and define my third point on the same beam. I'll bring it close and define this as my third point right there. Right click and interrupt to terminate that. So the moment you finish that, you'll find everything has been populated accurately and neatly along this curvature. So imagine, white note for this polar array, how long would it take you to distribute this accurately along this curvature? Now this is how it looks, and you can play around with the number of objects here. If you need 250, it will be right there for you, 250, and that will be arranged and be spanned accurately. So we have 250 of this, which defines also the center to center distances between these two beams. Now I'm okay with 250 number of objects right there, so then the rest will be deleted once you've defined exactly what you want. So I'll select all this, and prior to copying it down here, first of all I want to be sure of my point of copying. I'll come to points and pick at any position right here, and I want to copy this point. I want to transfer this point to the bottom end here. I want to transfer this point to bottom end here, and I'm not sure whether that is the accurate position. I need to confirm that. I'll come to points once again, and I'll snap right here, and I'll snap right there and try to locate the midpoint here. This is the point I want. So once I've clicked on that, right click and come to copy, I'll just pick this point right there and transfer this point to the bottom end right there, and all the members will be transferred at the bottom end. That's very interesting, and that is very easy to do. Now the next one is we want to add more braces on this. Don't mind about this. This will be rectified when you start connecting these braces to the main beams. So we are still just arranging everything in place to be the exact and then in the best position possible. So I'll come to navigate and come to that. So once again, I'll come to edit. I'll come to points here once again, and I want to define that to that. I want to get the midpoint here. I'll come to online point and snap on that spot and snap on this spot right there. Click apply and accept that, and you want to transfer the same thing on top here. I'll come to view, I'll come to navigate, and I want to transfer this point. I'll press Control and select on that, and I want to copy this. I want to copy this from that spot and take it down here. Take it down right there. So I want to get the midpoint between these 2 points. I'll come to edit and come to points. Select on that, bring it here, and we have a midpoint right there that will help us in creating a beam. I'll snap there, and move all the way to this midpoint right there. Perfect. Now if I come to view here, I'll be able to turn this round, and you can be able to see this has been placed accurately on top of that. So we need to reposition this. Double click on this and come to middle, and that will be taken to the best position possible. So this is how it should be. Now we want to populate this along these curved beams. Now I'll come to this member. I'll come to polar array, double click on it. I'll select on this member to be populated. I'll press my middle button on the mouse and snap right or snap right here. Then move all the way to this far end here, this at the bottom end here, to define my third, my second. Then I go to my third point and make sure what you're doing is correct. Right click and I'll define this as my third point, the bottom end here, and let's see whether everything is correct. It's not correct because we've done something in between the command, and some command rejects the instruction given prior to that. I'll double click once again and start defining it once again. I'll select on that, press your middle button on the mouse and select this as your first point or first position or point. Then move to the bottom end here and define that, and move this far end and define this as your third point right there, and that's how it will look like. We have all these populated accurately here. Perfect. Now what I'm going to do here is very simple. It's very simple. I want just to transfer this to this end, copy this to this end. So I'll pick on it, right click and come to special copy here, and I want to copy this far end by 2.5 meters. Let me just get rid of that. So which axis are we going to use? We are going to use the Z axis. I'll paste that dimension right there and remove this negative sign because we are moving in the positive direction. Then click that, so everything will be copied in the right position, as you see. So these are the braces that we intend to use. So I'm going to place another bracing. I'm going to place another bracing here. Right here, I'll come to navigate. We'll make sure everything is done perfectly right. So let me just do that here. I'll come to steel once again. I'll come to steel beam. I'll snap right there and move all the way to center of that beam. So once I've done that, I'll come to polar array once again and take it into a position that I'll be able to see it perfectly, and I'll close this first because I want to rotate it and see it clearly. I'll turn that like that. So I'll invoke the polar array tool, then I'll select this member, right click and pick this as my first position, then move out, and I'll define this as my second point, then move the other end and define that if we'll be able to reach it without any obstruction. Unfortunately, we cannot reach it because we have an obstruction, and that will force us to terminate that command, which will break the communication or in that process. Now I'll invoke this command once again and come here and select this member, right click, press the middle button on the mouse and define this point as our first point. Now I'll come all the way to this end and define this as my second point, then go the other end and define my third point, this far end right there. So you'll be able to see it's not accurate because the point seems to be not placed accurately. It's not okay, and we need to correct that. If I come to navigate here, you'll be able to see that there's something wrong, slightly wrong here, and that need to be corrected. So what I'm going to do, once again, double click and do work on that process once again. So I'll make sure the position that I'll be defining as my points must be accessible. So let me go back here. And turn this into a position that I'll be able to access. Now I'll invoke this polar array command and select this member, press my middle button on the mouse, and I'll snap on that location as my first point and move all the way to this midpoint to define it as my second point, then move to the other end and define my third point. So I'll make sure that these positions are accurately defined. So you can see that they're perfectly done, and I'll come to navigate and try to turn that round. I'll close this, come to navigate and turn this round. This is how it looks now. This is how it looks, and I want to copy this to this end. Just pick on this, right click and come to special copy, click linear and copy it to a z-axis, and that's all. We've copied that to the axis. Come to navigate and rotate this. This is how it looks. And this is how it's done. Perfect. Now once you've done this, and now what we are going to do, it's very simple. We are going to deactivate the assembly so that we delete whatever we don't want and remain with whatever we want. Now I'll come to select objects in the components and select on that. Then the rest I'll just select and delete because you don't need them. I'll select on that and delete, select on this and delete, select everything don't need and delete, because we don't need that circle to be completed. We wanted it to because you cannot define this without creating a full circle to get whatever we want. I'll delete on that, I'll delete all that and delete that, this one and that one. So we have this curvature in place, and this is how it looks. This is how our curve looks, and this is how our curve looks here. Perfect. This is how it looks. Now always don't forget to save your work. Make sure you save your work, and for today I think whatever I've just explained or whatever I've just done in front of you, I think this will help you in creating something similar to this or something closer to this. Remember, this is just part one, and we'll go step by step until we hit the end of this tutorial with once you've got the information on how to do this, you can do it by yourself. And the tools, mark the tools that we've used the polar array tool to populate all these members, all these braces, to support this curved beam. And now we've calculated the height of our curvature using the chosen distance, center distance of a circle. So once you get this height, this curvature height, you can either go with the way of calculations, or once you get this height, you just use the cambering method. You feed in the camber, and this curvature will come, and you copy and offset and copy these beams to create a braced curved beam. So remember, our bridge will come on top of this. Our footbridge will be supported. Will have columns sitting on top of this curve. So remember, at the bottom end here is a river, so that's why we are creating a curvature, so that in any loading subjected to this curvature, the curvature will try to offset this curve. So that's how it will work. Now I don't need to explain so much because this should be self-explanatory, and then let's meet on the next tutorial, which is part 2, and you'll be able to see everything done in step by step. Thanks a lot for watching this video, and let's meet then. Bye bye, and don't forget to subscribe to this channel, and please be safe because we have this coronavirus. Please be safe, be isolated, quarantine, and bye bye.